Hello, my name is Stephen Daniel with the Avaya Serviceability Engineering team. This video is about the Avaya Secure Access Link solution and egress-based connectivity model. The Avaya Secure Access Link solution provides a very robust and secure remote access and alarming architecture, all of which is based on an egress-only connectivity model and all of which operates entirely over the internet. But what does this mean? Well, in simple terms, it means that all traffic to and from your Avaya devices always originate from your environment and, more importantly, always travel in one direction, outbound, hence the name egress. By deploying a Secure Access Link gateway at your premises, you can manage remote access and alarm traffic for all of your devices using this model. What's more, all of this happens using a single outbound port of 443 over the HTTPS protocol. This makes deployment of cell effortless and network access control much more manageable. To see how this works, let's work our way through this diagram, which illustrates the different activities that occur. As you can see, we have three parts to this diagram. On the left, we have what represents the Avaya Support Center. In the center, we have the network or the internet cloud. And on the right, we have the customer premises or customer network. Now, before we can understand how this model works, it's important to understand how a traditional connectivity solution works. In most instances, a user needing to connect to a given device will have some form of direct access to a particular device, whether that's through a modem connection or a VPN solution with NAT in place. In either case, the end user will be able to establish a direct or indirect port-to-port dialogue with that end device, which is, it will be able to form a TCP socket with a far-end, near-end IP and port combination. With Secure Access Link, this does not occur. Rather, the Secure Access Link gateway is the only device on your network that will ever establish a port-to-port connection to your Avaya devices, and then proxy all communication back to Avaya for these given devices. But it gets even better, because it does so in a way that even a direct connection to the cell gateway is not required. Let's now walk through how this works. Let's suppose the user on the left at the Avaya data center wants to connect to this communication manager or CM server in your network. The user, once authenticated via two factors at Avaya, will first need to make a connection request with the Avaya concentrator remote server. This connection request never leaves Avaya, however, but rather sits and waits for polling messages from the cell gateway, which occur every 30 seconds. The polling messages from the gateway, among other things, are looking to see if there are any pending connection requests for any of the devices it manages. In this case, there would be one pending request for the CM server from this user. What happens next is the gateway, now aware that there is a pending request for the CM server that it manages, begins to establish a port-to-port session with the CM and, in parallel, prepares to securely tunnel this remote session back to Avaya. This session can be any protocol that the CM server supports. It may be SSH, or perhaps even an HTTP session. At this point, the cell gateway and concentrator remote server at Avaya are managing this communication over HTTPS using standard HTTP request methods, primarily GET and PUT. The user, on the other hand, has the perception that they are conversing directly with the desired system, though this in fact is not occurring, and in actuality, the cell environment presents the CM server as a local host or IP address 127.0.0.1 to the end user. What's really happening is that the gateway is acting as the in-between, managing all bidirectional communication on behalf of the user and the device using a series of HTTP GETs and PUTs. For example, if this were an SSH connection, when the CM server presented the login prompt to the cell gateway, the gateway using HTTP PUT would send that information upstream to the concentrator remote server, which then in turn would present that login prompt to the end user's application, their PuTTY window for example. Similarly, when the user enters a username for the login prompt, that request never leaves Avaya. Rather, the gateway, now using HTTP GET, will retrieve that information from the concentrator remote server and then present that to the CM server. As the session moves on, the cell gateway will continue to repeat this process for all interaction occurring between the user and the CM server, fulfilling each and every request. The sophistication behind all of this is that throughout the entire session, never once did the user communicate directly with the CM server, and more importantly, the cell gateway was the only device originating any traffic all of which was outbound. And this is how the Avaya Secure Access Link solution operates using the egress-based connectivity model. Thank you for your time today. We welcome comments, questions, and feedback at mentor@avaya.com or on Twitter @AvayaMentor. For more details or related information, please visit support.avaya.com. Thank you for choosing Avaya.